Okay, so in this chapter, I'm going to explain about one sample test of hypothesis. And the study case of this is the Zingbling jewelry store. So first, what is hypothesis? In statistic, one sample test of hypothesis are statistical tests that are used to make inferences about a population based on a single sample of data. The goal of this test is to determine whether the sample data is sufficient evidence to support or reject a particular hypothesis about the population. Next, there are two types of hypothesis. The first type is the null hypothesis or the H sub zero. A null hypothesis is a statement that suggests that there is no significant relationship or difference between two variables being studied. Researchers use it to assess statistical significance by comparing their findings with that of a null hypothesis. For example, a researcher may hypothesize that there is no difference in the test score between students who study on their own and those who study in groups, and test it against a null hypothesis that there is a difference between the two. The second one is alternative hypothesis or the HA. An alternative hypothesis, a statement that suggests that two or more variables are related or that there is significant difference between them. It is usually tested against a null hypothesis to determine statistical significance. For instance, a researcher may hypothesize that there is a positive correlation between job satisfaction and productivity and test it against a null hypothesis that there is no correlation. So, the step of hypothesis test is first we determine the null hypothesis and alternative hypothesis. Second one is the calculate the critical value. And the third is test statistic. And the fourth, draw the conclusion. So first, we determine how to calculate the one cell and the two cell. First, a one cell test is used when the hypothesis states a specific direction if the effect being tested. For example, if we want to test whether a new drug improves memory, a one cell hypothesis will be that the drug improves memory, and the tail will be on one side of the distribution curve, representing the likelihood of extreme improvement, and the one cell is shown in the first and the second graph shows in the picture. On the other hand, a two-tail test is used when the hypothesis does not specify the direction of the effect being tested. For example, if we want to test whether a coin is biased, a two-tailed hypothesis will be that the coin is not fair, and the two tails will be on both sides of the distribution curve, representing the likelihood of extreme result in either direction, heads or tails. In summary, the key to distinguish between one tail and two tail is to look at the directionality of the hypothesis being tested. A one tail hypothesis tests for an effect in one direction, while a two tail hypothesis tests for an effect in other direction. And that is shown in this picture when where the one tail is include right tail and the left tail test, and the two tail test is equal both sides of the two tail. So first step is the second step is determine the critical value or the significance level of test. The significant level of a test refers to the probability level at which a statistical test rejects the null hypothesis. This level is typically predetermined before conducting the test and is denoted by alpha. A common significance level is 0.05 indicating that the observed result will occur by chance in 5% of cases if the null hypothesis were true. If the calculated probability or the p-value of the test result is smaller than the significant levels, the null hypothesis is rejected in favor of the alternative hypothesis. The, the choice of a significance level reflects the trade-off between the risks of type 1 error or the rejecting the null hypothesis when it is true, and type 2 error or failing to reject the null hypothesis when it is false. So here is the test statistic. The test statistic is equal one sample mean, and there is two formula. First is the test statistic when a population known, and the second one is test statistic when a sample is known. So the formula is for this population known is Z is equal X bar subtract mu divided by sigma is equal square root of n, where the X bar is the sample mean, the mu is the population mean, the sigma is the population standard deviation, and the n is the sample size. And the sample test statistic is T is equal X bar divided by mu. No, sorry. X bar is subtract mu divided by S is and divided by square root of n, and the f of the freedom is equal n minus 1. And X is equal sample mean, and the sigma is, no, sorry, the mu is population mean, and the S is sample standard deviation, and the n is the sample size. And the last step is the draw a conclusion. If the p-value meets the significance level requirements, then the alternative hypothesis may be valid and we may reject the null hypothesis. In other words, if the p-value is less than significance level, or if you calculated the p-value is 0.02 and your significant level is 0.05, then you can reject the null hypothesis and accept your alternative hypothesis. So in this picture shown below, to reject H sub 0 or the null hypothesis is if the statistical value is in the shaded area, where the minus 2.58 is the critical value and the 1.55 is the statistical value. So if the 1.55 is in the shaded area, then do not reject the H sub 0 or the null hypothesis, while if 1.55 is in the area of the not reject, then not the shaded area, then we reject the H0. So the example of the study case for the population known, a Zingbling jewelry store want to test the claim that the average order value is different from $1,000. The business collects a random sample of 100 orders and finds that the sample mean order value is $970, where a population standard deviation is $200. So test the claim at the significance level of 0.05. So the solution, the degrees of freedom for the test RDF is equal n subtract 1. So 100 subtract 1 is 99. Using a t-table or calculator, we find the critical t-value for a two-tailed test, a significance level of 0.05 and 99 degrees of freedom to be more or less than 1.98 and 4. We will use a significance level of alpha is 0.05, which means we want to be 90% confident in our conclusion. And that is shown in the table below in the confidence level. Next, H is, or the null hypothesis, the average order value is equal 1000, and the alternative hypothesis, or the average order, is different from 1000. So next is we going to use the formula for the population noun. So the test statistic for the population noun is Z is equal X bar minus mu divided by sigma divided by square root of n, and we get 970 is subtracted by 1000 divided by 200 and divided square root of 100 is equal minus 0.50. And that show the graphic below that the t value is minus 0.1 is less than minus 0.984. And the conclusion is, since the calculated t value of 1.5 is less than minus 1.984, we reject the null hypothesis and conclude that there is sufficient evidence to support the claim that the average order value at Zingbling jewelry store is different from 1000. So the case for this is we reject the null hypothesis because there is sufficient evidence to support the claim that the average order is different from 1000. The next is for the example of sample is known. A Zingbling jewelry store manager wants to test whether their new advertising campaign is effective in increasing sales. They take a random sample of 30 customers who came into the store during the advertising campaign period and record their total purchase amount. The manager who wants to test the hypothesis that the average store that purchased amount per customer during the advertising campaign period is greater than $100. So test the claim at the significance level of at 0.05. In the note below is shown the list of the customer who came into the store during the advertising campaign period. So in the solution, using a tree distribution table with degrees of freedom, or DF, is equal 29, and the sample size subtract 1, and a significance level of 0.05, we find the critical value of t to be 1.699. And the H0 is equal mu is no more than 100, and H alternative hypothesis, mu is larger or more than $100. And in the table, T table shows in the significance level of 0.05, where the highlight in the red one, it shows the significance level of n, the critical value, for the first example and this example. So we're going to put it in the formula, and the t statistic computed as follows. So the t is x bar subtract mu and divided by s divided by square n. So 100.67 subtract 100 divided by 60.35 divided square root of 30 is equal 0.224. And the graphic shows below that the calculated t value is 0.99, is less than the critical value of 1.699. So we fail to reject the null hypothesis, and this means that we do not have sufficient evidence to conclude that the advertising campaign significantly increased the mean purchase amount at the 0.05 significance level. So, thank you for the attention and have a nice day.